Hi friends, today I am giving a lecture on merge sort in divide and conquer technique in design and analysis of algorithms. So divide and conquer technique is one of the algorithm design technique. It is a very simple technique. It is very easy to understand. In divide and conquer technique, mainly it consists of two phases. First one is divide phase. In this phase, the given problem can be divided into two subproblems based on the mid value. Again, this subproblem can also be divided into some another subproblems by using the mid value. So this procedure is repeated until each and every sublist contains a single element. Next, then recursively solve each and every subproblem independently. Next, second phase is conquer phase. In the conquer phase, we have to combine all the solutions of the subproblems. So then we are getting the final solution to the given problem. So now merge sort is one of the application of divide and conquer technique. So by using divide and conquer technique, how to sort the given n number of elements using merge sort. So suppose we can take an array. So this is given array. So its size is 0 to n minus 1. Okay. So that is 0 comma n minus 1. So this is the size of the given array. So this array contains n number of elements. So first element start with 0 and last element end with n minus 1. So this given array can be divided into two sub arrays or two halves. So this is the first half and this is the second half. So what is the size of the first half? That is 0 to n by 2 minus 1. So this is the size of the first half, 0 to n by 2 minus 1. So this is the mid value. So 0 to n by 2 minus 1. And what is the size of the second half? So that is n by 2 to n minus 1. So this is the size of the second half. So the total size of the array is 0 to n minus 1 or 1 to n. So this array can be divided into two sub arrays or two halves. So this is the first half and this is the second half. What is the size of the first half? So 0 to mid value. So mid value is nothing but 0 to n by 2 minus 1. Next, what is the size of the second half? N by 2 to n minus 1. Next, recursively solve each and every half. So recursively sort. So first half and recursively sort second half. So finally we are merging the sorted of first half and second half. So then finally we are getting the sorted array of the given list. So in this way we have to solve the given problem. So by using merge sort, using divide and conquer technique. So here to sort a sequence of n elements, the following steps are followed. First step is divide the given array into two sub arrays. This is the first sub array and this is the second sub array. So first sub array length is 0 to n by 2 and the second sub array length is n by 2 to n minus 1. Next, recursively sort each of the two subarrays. So recursively solve the first hull and recursively sort the second hull. So finally merging the two sorted subarrays. So this is the sorted first hull, this is the sorted second hull. Then we are combining the two sorted hulls. So finally we are getting the sorted array. So in this way we have to sort the given array of n elements using merge sort by using divide and conquer technique. Next, go for example. So now consider the example problem. Sort the following n elements using merge sort. So these are the following elements. Now we have to sort the following these elements by using merge sort with the help of divide and conquer technique. So now, we have to use indexes, that is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and this is low value. The first element can be taken as low value and the last element can be taken as high value. So now the given list is divided into two sublists by using the mid value. So mid is equal to low plus high by 2. So by using this mid value, the given list is divided into two halves. So that is 0 to mid value and mid plus 1 to high value. So then first we have to find out mid value. So mid is equal to low plus high by 2. So low plus high by 2. So that is equal to low value. Low value is 0. High value is 9. So 9 by 2. So that is actually it is 4.5. Now we have to take in the floor value. Floor value is 4. Next. So from 0 to mid value is 4. 0 to 4, this is the first sublist. Mid plus 1, that is 4 plus 1, that is 5. 5 to 9, this is the second list. So then, 310, 285, 179, 652 and 351. So this is the first sublist. So this is index value 0, 1, 2, 3, 4 and this is a low value and this is high value. Okay, next mid plus 1. Mid plus 1 is 5, that is 423, 861, 254, 450 and 520. So index value 5, 6, 7, 8, 9. So this is low value and this is high value. Next. So the first sublist contains 5 elements. So 0 to 4. The second sublist contains 5 elements, that is 5 to 9. So again we have to apply the divide and conquer technique for the first sublist. So now mid value is equal to low plus high by 2. Low value is 0, high value is 4, 0 plus 4 by 2. So that is equal to 2. So again this first sublist can be divided into two sublists based on the mid value. So 0 to 2, that is the first sublist. 3 to 4, that is the second sublist. So that is 310, so 285, 179. So this is the first sublist. The second sublist contains only 2 elements. So 652, 351. So this is 0, 1, 2, and this is 3, 4. So again, this is the low value and this is the high value, and this is the low value and this is the high value. Okay. So again, this first sublist can be divided into two halves based on the mid value. So mid is equal to 0 plus high value, that is 2, 0 plus 2 by 2. So that is equal to 1. So again, this first sublist can be divided into two halves. So 0 to 1, that is the first half, and only 2 contains second half. So that is 310, 285. So this is the first half, and 179. So this is the second half. And these are, it contains only 2 elements. So 652, 351. So that is 3. This is 4. This is 0. And this is 1. And this is 2. Okay. Now we have to combine again. This first sublist contains 2 elements. So then the second sublist contains 2 elements. So then we have to take the mid value. So mid is equal to 0 plus 1 by 2. So that is 0.5. That is, we can take as 0. So that is, 310. This is the low value and this is the high value. Okay. So 310, 285. Next contain 179. Again, we can take the mid value. So mid is equal to 3 plus 4 by 2. So that is 3.5. That is 3. So here, 652 is 351. So this is a low value and this is a high value. Okay. So now we have to combine. So here each and every list contains a single element. So now we have to combine these elements by sorting the elements in the sublist. So here the first sublist contains 310. So a single element cannot be sorted. Now this element is combined with this element. So then we have to put them in sorted order. So that is 285, 310. Okay. So this is the first sublist. Next. So this is the first sublist, 285, 310. Again, this sublist is combined with second sublist. Now it contains 179, 285 and 310. So this is the sorted order of the first sublist. So again, it contains only, the first sublist contains a single element, the second sublist contains a single element. So then put them in sorted order, that is 351 and 652. So this is the first sublist. So finally we are getting the first sublist elements are 179, 285, 310, 351, 652. Okay. Next, go for second sublist. Here mid is equal to 5 plus 9 by 2. So that is 14 by 2, that is 7. So 5 to 7 is the first sublist, 8 to 9 is the second sublist. So that is 423, 861, 254. So this is the first sublist, and second sublist contains 450, 520. Index numbers are 5, 6, 7, 8, 9. Okay, again this is low value and this is high value. Again this is a low value and again this is high value. Okay, now the first sublist contains 3 elements, the second sublist contains 2 elements. Again, for the first sublist, we have to apply the divide and conquer technique. So here, mid is equal to low value is 5, high value is 7, 5 plus 7 by 2, that is 6. So then 5 to 6 is the first sublist, only 7 is there in the second sublist. So that is 423, 861. So it contains the first sublist and the second sublist contains only the 7th element. So that is 5, 6, that is 7. So this is low value and this is high value. So this is also low value and this is also high value. So this is also low value and this is also high value. Okay. So again we have to apply the divide and conquer technique for the first sublist. So here mid is equal to 5 plus 6 by 2. So that is equal to 5. So again this list can be divided into 2 sublists. So that is 423 and 861. And it is contains only a single element, that is 254. Okay. So this first sublist is compared with the second sublist. If the elements are not in sorted order, put them in sorted order. So that is 423, 861 is combined with 254. Okay. So the first sublist contains 2 elements. The second sublist contains a single element. Now we have to combine these 5, 6 and 7th element and put them in sorted order. So that is 254, 423, 861. So this is the sorted order. Next, go to this one. So here mid is equal to 8 plus 9 by 2, that is 17 by 2, that is 8.5, that is 8. So that is 450. First list contains only 450 and second list contains 520. So now we have to combine these 2 sublists if they are in sorted order. So there is no change. If they are not in sorted order, put them in sorted order. So then finally we are getting, so that is 450 and that is 520. Okay, this is 8 and this is 9. So now 450 and 520. Now comparing these first sublist with the second sublist. So that is 254 is compared with 450. So 254 is the less value. Next, again this value is incremented, that is 423. 423 is compared with 450. So then 423 is placed in the sorted list. Next, 861 is compared with 450. So 450 is the less value, then it is incremented. Next, 861 is compared with 520. So 520 is the less value. Next, last one is 861. So this is the final sorted list and this is the final sorted list. Now, the first sublist contains 179, 285, 310, 351 and 652. So this is the first sublist. Next, second sublist is 254, 423, 450, 520, 861. So the first sublist contains 5 elements. The second sublist contains 5 elements. Now we have to merge these two sorted sublists. Finally, we are getting a sorted array. Okay. So how we are merging these two sorted sublists? Okay. First, 179 is compared with 254, which is the lesser value. 179 is the lesser value. So this lesser value put in final sorted array. Now it is incremented to this value. Next, 285 is compared with 254, which is lesser value. So 254 is the lesser value. So then this value is incremented to this point. Next, 285 is compared with 423, which is lesser value. 285 put in the sorted array. So then it is incremented to this value. Next, 310 is compared with 423, which is lesser value. 310 is the lesser value. So now it is incremented to this value. Next, 351 is compared with 423, which is lesser value. So 351 is the lesser value. This value is put in new sorted array. So again this is incremented to this value. Next, 652 is compared with 423, which is lesser value. So 423 is the lesser value. So then it is incremented to this value. 652 is compared with 450. 450 is the lesser value. It is put in new sorted array. So then this is incremented to this. 52 is compared with 520. So 520 is the lesser value. So again the control is incremented to this value. Next, 652 is compared with 861. So 652 is the lesser value. This value is put in new sorted array. So the first sublist completed all the elements. So then only one element is there in the second sublist. So this element is directly added to the new sorted array. So this is the final sorted array of 9 elements. 10 elements. 10 elements. And this value is 0 to 4 and this value is 5 to 9. So this is the final array. So that is 0, 9. Final sorted array. Final sorted array. Final sorted array. Okay. So this is the example of sorting the following n elements using merge sort by using divide and conquer technique. Okay. So thank you. Next we go for 3 calls of merge sort.